Hey everyone, today, Evey part 3. So, we literally are going to fill in the blank today. This is the rubber isolator that I make for the 2GR, and it goes into that mount, and this is it's rubber, which means it doesn't have the squeak from polyurethane, which I really appreciate, but it's a higher durometer, similar to actually to the TRD mounts. So, since this is going to be a production part, that means it needs to be kicked off rather soon because it's going to take 4 to 6 weeks to get through production. So we're going to drop this engine in. We've got 1, 2, and the third motor mounts on the back. You know, those are all on the transmission in the MR2, so that makes our job easy. And all we're going to do is locate this in the chassis at the appropriate place. And I'll make some kind of plate, and I'll probably weld directly onto here. It's just stainless. Our goal is just to locate this in space relative to these 3 holes so that then I can pick all that up and make the mount out of it. So let's get to it. Do you see that down there? That means, yeah, over 5,000 of you guys have clicked the button over there. That's crazy. That blows me away. I'm just having fun. I'm going to continue doing this. And this is Project Evey Part 3. If you are new to the channel, this is a Toyota 2.5 liter 4-cylinder that I'm going to be using to take the MR2 drag racing record naturally aspirated. We might go after the turbo record later, but the turbo record is ridiculous right now, and I think it's going to get even more ridiculous soon. So anyways, that out of the way. Naturally aspirated right now. So 2.5 liter, we might bump it up to 2.7 liters using factory parts. The goal is to make it so that this can be replicated by all of you guys. So that means as many production parts as possible, and the motor mount is one of those critical production parts. So I want to get that out of the way as soon as possible. And if you go and look at the previous episodes, there's cams coming, and I've got pistons coming for myself. Depending on how that goes, I might make those available also. And plenty more parts down the pipeline. I mean, to get to 350 horsepower to the ground, which is currently our target, it's going to take a fair bit. So first things first, we got to drop this into the car. And I did say drop. I think there's actually a chance, without this stuff on here, or on here, you know, the intake or the exhaust, I might have to take these mounts off here. I might actually be able to get this motor in from the top, which would be a lovely change because everything in the MR2 normally has to go in from the bottom. So we're going to give it a go. Let's see if it works out. I haven't tried it. I don't know if it will. All right, let's get to it. And just like that, we have the MR2 in the shop. All right, so we got 2 motor mounts in, and I apologize, I should have brought the camera in closer for the rear mount, but I'll bring it in closer for the front mount. And speaking of the front and rear mount, I know you guys have heard me complain about polyurethane mounts many times before, but this, I gotta say, is the one place where it's acceptable. For setup like this, it works really well because you don't have to worry about as much variance in here from the weight and whatnot. So I'm using these poly mounts that I've had for a while, just kind of kicking around the shop. They probably came on a card that I bought. And yeah, so let's get in closer and let's install the front mount. At this point, we've got 3 known good locations, but the front mount has a little bit of a slot. So that allows adjustability for everything. And we want to put this so that the engine essentially sits near the middle, but more importantly, that the angle is correct. So when I jacked this up, I tried to put it kind of even, and you can see it's off by 0.4 degrees. And that's not a big deal. We can just zero this, and then we can place it here and see if our engine is level relative to our chassis. The way we're going to adjust that is I took this bolt pattern here. This is the Scion TC engine mount. And I just transferred it to a piece of scrap, very precisely to a piece of scrap. And then I took the 2GR mount that I used for this side, and I just took one and I welded a piece of scrap on top so that it wouldn't rotate. And I'm simply going to take this piece of 1-inch tube, weld it like this, all in the chassis. But importantly, I'm not going to weld between here, because then this whole thing is intentionally going to be low, and then I'll use the gauge, the angle gauge here, to set the angle just right in the engine so that this thing sits right with the load on the bushing. And then those shims, I'll just use metal shims. I'll bring the welder in, zip zap, and then I'll have in 3D space where everything needs to be relative to each other. So let's get to that. And there it is. In 3D space, we have everything located. So I just need to pick up these points, and interestingly, I guess it probably makes sense, the straight here, which is straight on the chassis, ends up being about straight across these mounts. So that's probably because the angle's mounted at the right position. I mean, either way, we're not going to change the angle because it's set by those other mounts. All right, so yeah, all I got to do is pick up all of these points and design a mount. Some of this is going to be a bit annoying since this bolt here is right in line with these bolts, but yeah, I've got some ideas. So now that we have this lovely part here that tells us where all of our points are, along with where our bushing needs to be, it's time to just digitize all of these points so we can put them in the computer and design a model that fits all of this and get that manufactured. So the way we're going to do that, there's a DRO on the, well, okay, there's a DRO just off screen there that you can't see, but it's fine, you don't need to see. And we've got a 2-inch dial indicator. The dial indicator ends up being useful when you're trying to find a center like this. You can just sweep back and forth and find 50 thou down here and 50 thou down here, and next thing you know exactly where your center is. And then a recent upgrade to my digitization station is a coaxial center finder. So this, I used to just use a test indicator and find the holes the old-fashioned way, by spinning this around and just going around and around and around until everything's fine. But this is a beautiful thing. It makes it a lot quicker. All right, so I'm going to pick everything up here. All I need is these 4 holes and this here. Now, this thankfully is centered in here and it's a known diameter, so all I need to do is pick up 1 center point here and 1 center point here, and from that in the computer I can draw the rest. And now that we've got these 4 wonderfully cryptic pages of information that have some numbers in millimeters and some numbers in imperial, we're going to take that and we're going to make this model. So this model right here locates all of my points in 3D space, and now I just need to make it look pretty, but that's going to take a little bit, so that's not going to be on this episode. Now, with the mount digitized, I'm going to go ahead and kick off what needs to happen there to make that a production mount. It should be the same price as the 2GR production mount because it's a similar difficulty. So I'm going to aim for that same $349 price. And the reason it's more expensive than the spider mount is because it includes an actual rubber mount. And I hate the squeaks of polyurethane. So I want to make it rubber mounts. Now, this is a drag car, so what we might find really quick is that it doesn't make sense for me to use rubber mounts, but it makes sense for just about everybody else that's going to be using these products, so that's what I want to build. We might end up eventually needing solid mounting this thing to the frame. Probably not at the power levels we're at yet, but who knows? We'll cross that bridge when we get there. So now if we look at our final position, our clearance here, we can see it's not a heck of a lot. It's probably about 4 millimeters or so. But it's also only going to rock forward and backwards. So if we take this out here, or we just kind of smash it in, I'll probably take it out because I want to lose the weight. Then it'll be just fine. Now keep in mind, this is just your prop rod support, and before you say that, you know, this is a strut reinforcement, I'm sure it's adding some strength reinforcement, but if you look at the other side, you can see that that one also ended where they had the last use for it, right, which is these bolts here. And this one, of course, ends where they have the last use for it. So this, I'm pretty confident, is just an addition that's there to add fastening points. The other neat thing I wanted to show you, check this out right here. So I just got this message from the machine shop working on the cams. What you see there is the first machining operation for all the camshafts for the 2AR. That is, as soon as I get those in my hands, which should be about 2 weeks, maybe 3 weeks or so, I will drop it in a car. If Evey is ready to go, I'll use Evey. Otherwise, I'll use Tanya, the 3rd gen Spider, the white one, the race car. Yeah, and then we'll take that to the dyno. My plan there is to get the number 2 grind that I made tested out. That should be about 250 wheel horsepower if you're using, again, right, that same header that I'm using, same intake manifold, well, stock intake manifold, and my mass airflow velocity stack. With that combination and the appropriate tune, I'm expecting that to make 250. Now, what I don't know for sure is, are we going to need to go with the larger displacement to get that? Or are we going to need to go with a higher compression to get that? But either way, we're not going to need to do both because both is not available from the factory. And if it doesn't get it in this form, then I'm actually going to throw it in a 2AR-FE first, because that's much cheaper to get. The 2AR-FE pistons will fit right into a 2AR-FE and change it from a 10.8 to 1. Was it 10.4? I don't know, it's on screen right here, the right number. And all the way up to a 12.5 to 1 compression ratio, which is right at the limit that this thing wants on premium fuel without any alcohol in it. But nothing that you can't control with a little bit of active knock control. Remember, I raced it. Now, here you can see some footage where I raced it. No issues. The ECU had to take a couple degrees of timing out here and there. I definitely would have had more power on alcohol, but it ran perfectly fine all weekend. So that is an option. And those pistons are just $60 a piece, $65 a piece, maybe straight from Toyota. So hopefully that won't be needed. It definitely won't be needed to get good numbers out of it. It just might be needed to achieve that 250 target that I'm talking about. And yeah, so some of those other camshafts are much, much, much bigger. I'm hoping that one of those camshafts ends up being the camshaft that goes in the final engine for Evey that is going to get us all the way to 350 wheel horsepower, but it's a little early to tell that. You know, the 250 wheel horsepower number I feel pretty confident about because I've got an engine in Tanya right now that makes 231 to the ground, and I've got an engine sitting over there that made 241. So I've got a pretty good idea what it takes to make that kind of power in these engines. So 250, not a huge leap. I feel pretty confident that we're going to make that number. So something else neat I wanted to point out is this guy right here, which some of you guys will recognize as the factory exhaust manifold with the primary catalytic converter. It bolts right on in here. There's, you know, unlike the 3rd gen MR2, there is no chassis getting in the way. There's absolutely nothing you have to cut or trim or hammer. There's no gas lines near it. There's no clutch lines near it. It just fits beautifully. So for you guys out in California looking for a modern motor, now of course you'll have to run this. You'll have to run the stock airbox. So you're not going to get the 205 horsepower to the ground. But effectively what you'll get is something very similar to what the MR2 got in turbo trim. So something rated to about 200 horsepower to the crank, maybe even a little bit more. So the feel with one of these, which should be able to be made emissions legal rather easily, is going to be effectively something like the Beams upgrade, which plenty of people have done that and have really enjoyed it, except, right, Toyota's made about 4 million of these, so they're much more available. So if you want to build yourself one of these, not when the video goes live, but within a couple weeks in the description of the video, or you can always just go to my site. There will be a pre-order, and then probably 4 to 6 weeks after that, there will be actually parts that will be shipping out for the motor mount for this thing. So hopefully some of you guys want it out there, and purchasing that kind of thing helps me keep running this thing. Really, I have I'm not really good at pulling money out of this company. I just keep rolling it back in for more and more products. So the more you guys support this stuff, the more neat stuff I come out with. So I'm having fun. Hopefully you guys are enjoying yourselves, and yeah, have a good day. We'll talk to you guys later. All right, what the hell? I think this car must have had a nest of whatever the hell these are. And now they're angry in here. Damn it. All right, well, guess we got to deal with that problem now.